It seems like every day NASA announces a new asteroid that is a potential threat to Earth. With more than 1 million identified asteroids orbiting the Sun, it's a monumental task to keep track of all of them. Fortunately, most of these asteroids will never be a threat to civilization, but NASA estimates there are about 4,700 potentially hazardous asteroids with a diameter greater than 100 meters. This is big enough to cause regional devastation at the point of impact. Impact events like these happen once every 10,000 years on average. The goal of this video is to take a look at the 12 largest impact craters that have been discovered so far. An impact crater is what is left behind when a meteor hits Earth. The size of the crater depends on the kinetic energy of the meteor. If you remember your high school physics class, the equation to calculate kinetic energy is K equals 1/2 mv squared, meaning it is a function of velocity squared times the mass of the meteor. The average speed for a meteor colliding with Earth's surface is around 24,000 miles per hour. This depends on a variety of factors. Asteroids were formed near the beginning of the solar system, and their speed is mostly due to their orbit around the Sun. Now here's the thing. Most meteors burn up in Earth's atmosphere before any impact occurs. But when an asteroid is large enough, it smashes into Earth's surface. Fortunately, large impacts are extremely rare. All it takes is an asteroid of roughly a 1/2 mile diameter to have global impacts. And about once every billion years, an asteroid between 5 and 10 miles wide slams into Earth and causes a mass extinction event. In the very remote eastern region of Tajikistan, you will find the Karakul crater, which is 52 kilometers in diameter. This is right near the border with China and only a short distance from the ancient Silk Road. Estimated to have occurred roughly 1 to 5 million years ago, this is a fairly young impact crater that has filled with runoff from the nearby mountains. At the time of the impact, enough dust was sent into the atmosphere to have global impacts, and it has been suggested as a contributor to the cooling and ice cap formation in the northern hemisphere during the late Pliocene period. These days, the Karakul crater and its resulting lake is part of the Tajik National Park. It is easy enough to visit provided you're willing to take a long flight followed by a long drive to a remote part of the world. 11. In Queensland, Australia, you will find the Tukanuka crater. At roughly 55 kilometers in diameter, this impact is estimated to have occurred about 128 million years ago. While this was during the time of the dinosaurs, it was not large enough to have caused an extinction event. Australia is one of the easiest places to find impact craters because so much of the Earth's surface is empty. Due to its age, the crater is no longer visible on the surface. This is because of the natural processes of erosion such as flooding and surface creep. This crater was found accidentally when geoscientists were engaging in petroleum exploration. Impact craters that are no longer visible on the surface are usually found due to magnetic and gravitational anomalies. When a meteor hits Earth's surface, the impact compresses the Earth's surface in a way that crystals are formed, and the point of impact becomes much denser than the surrounding area. For large impacts, the gravitational anomaly that occurs is easily measurable with scientific instruments, and additional exploration of the site can then take place. One of the most interesting craters that is no longer visible on the surface is actually number 10 on this list, the Beaverhead crater. Heading to eastern Idaho in the United States, we find an extremely old crater estimated to be somewhere between 500 million and 1 billion years old. This crater is so old it occurred before the surrounding Rocky Mountains had formed. This dates back to the time before plants formed on the Earth's surface and before multicellular organisms had really begun to take a foothold. The size is estimated to be around 60 kilometers wide and is so old that the impact structure has shifted several miles from the original site. When the meteor struck the surface of the Earth, shatter cones were created deep below the upper crust. As the Rocky Mountains were formed, the upper crust shifted over time, while the lower crust, right above the mantle, remained in place. The original impact point is near the town called Challis, Idaho, where the crater that developed on the upper crust is likely spread out between Grouse Peak and the Beaverhead site. This shifting of a geological site is a common occurrence over hundreds of millions of years. Number 9. In far northern Russia lies a different type of impact structure, whose primary evidence is the presence of something called ejecta. All impact craters have ejecta, which is the debris that is found for miles around the crater itself. The crystals that are created from the intense heat at the point of impact can be found tens of kilometers away if the meteor is big enough. Estimates vary, but it is thought that the diameter of the crater is thought to be around 65 kilometers, but it could be much larger. Somewhere around 70 million years old, this region has been subjected to intense erosion from glacial erosion as well as the changing flows of rivers over time. Interestingly, just northwest of here, the largest nuclear weapon ever tested, the Tsar Bomba, was detonated. The energy released by the Tsar Bomba was about 50 megatons of TNT, which is about the same amount of energy as released by this asteroid. The reason the Tsar Bomba did not leave a similar crater is due to several factors, with one being that it was detonated in the air, and two because the energy released by a nuclear bomb is very different than that of an asteroid. Almost all of the meteor's energy is kinetic energy, which is released through the deformation of the Earth's surface, which is why they leave such large impact craters. A small amount of this kinetic energy is released as thermal energy, which is responsible for the melting and crystallization of rock that occurs at the site of the impact. Near Marokwang, South Africa, a 145 million year old crater, roughly 70 kilometers in diameter, was discovered in 1994. In 2006, scientists drilling the site managed to find a 25 centimeter chunk of the original asteroid at 770 meters, or nearly half a mile below the Earth's surface. Smaller pieces of the original asteroid were also found at other depths during the drilling. This was a very unexpected occurrence as previous drillings on other large impact structures had not produced such remnant of the original asteroid. It had been previously thought that the entirety of an incoming asteroid was vaporized upon impact. Pieces of the original asteroid can be seen in London's Science Museum. Number 7. Perhaps the most picturesque impact crater on this list is the Manicouagan crater in Canada. 85 kilometers wide and about 214 million years old, the impact dome and outer edges of the crater are clearly visible, especially with the help of the ring of water that surrounds this dome. Many impact craters have a dome at the center, which occurs when the Earth's surface is compressed, then rebounds back, thus creating an uplift at the center of the crater. The type of lake that forms around this impact dome is called an annular lake, which is derived from the Latin word annulus, which forms a perfect circle, which means ring. There are many such lakes around the world, but this is the largest and most perfect of its kind. Number 6. One of the oldest craters still visible on the surface of the Earth is Ackerman Lake in Australia. Nearly 90 kilometers wide and 600 million years old, the crater is easily visible since water has filled in the depression. This is what is known as a playa lake, meaning it is often a dry lake bed and only fills with water during heavy rains. If you watched my last video on mountain formation, then you know that Australia has been geographically calm for most of the last half-billion years. The mountains and geography here is old due to the lack of tectonic activity in this region. Due to the lack of geographical change, we are fortunate enough to see this crater highlighted when heavy rains fall. The presence of shocked quartz is found at the shatter cones at the center of this crater. These shatter cones are highlighted when the lake is filled. Returning to northern Russia, in Siberia lies a very large diamond field. This region of Russia is very remote with few roads, so this region lacked scientific study for many years. The remnants of a 90-kilometer wide crater are visible, and it is quite young at 35 million years old. This region has been designated by UNESCO as a geopark, a site of special geological heritage. The diamond field that is found is a result of the ejecta from the impact. The shock pressures from the impact instantaneously transformed graphite in the ground into diamonds within a 13.6 kilometer radius of the impact point. Due to the remote and northern location of the area, the fact that synthetic diamonds are easily and cheaply made, the diamond fragments in this area remain relatively untroubled. The amount of diamond and crystallization created at a meteor impact point depends mostly on the material the meteor is made up of and the type of rock and minerals present on Earth's crust in the impact region. Number 4. The Sudbury Basin in Canada is extremely old. Somewhere around 1.85 billion years ago, primitive single-celled organisms were just starting to emerge. This was long before Earth's last supercontinent, Pangaea, had formed, and was during the time of this Nuna supercontinent. Due to nearly 2 billion years of erosion, this basin has diminished in size, but the original crater is estimated to be about 130 kilometers in diameter. Number 3. By far the most famous meteor to strike Earth, the Chicxulub meteor is what killed most of the dinosaurs. The geological evidence shows that this impact occurred roughly 66 million years ago, which lines up perfectly with the mass extinction event at the end of the Cretaceous period. Measured at 180 kilometers in diameter, the impact created a mega tsunami which traveled for thousands of miles across the ocean, caused a seismic event, aka an earthquake, of around 11 on the Richter scale, which is about the upper limit of what the Richter scale can actually measure. This impact created a global dust cloud and a dramatic drop in global temperature, which is believed to be responsible for the extinction of the majority of life at the time. Life forms that survived the initial impact had to suffer through an atmosphere that was clogged up with dust and debris. Number 2. The largest known impact structure to have been extensively studied by scientists is the Vredefort impact structure in South Africa. This is nearly 2 billion years old and has an estimated diameter of 240 kilometers. Just like Australia, South Africa has been very calm geologically, being home to some of the oldest hills on the planet. What once were mighty mountains have eroded over billions of years to hills and highlands. Erosion has obscured most of what we would hope to see in an impact crater, but what remains shows that this was a multi-ringed impact structure, a partial ring of hills and the remains of the dome created by the rebound of rock below the impact site. Multi-ringed impact structures are more common with larger meteors with greater kinetic energy. Number 1 is a speculative impact crater called the Wilkes Land Crater in Antarctica. It's 480 kilometers wide and estimated to be between 100 and 500 million years old. This is a speculative crater because not enough scientific exploration has been done to understand this geographic anomaly. Gravitational anomalies confirm its existence, but its remote location makes it difficult to study in detail.